Now theorem 4 we are having, if fx and gx are differentiable functions, then fx plus minus gx are also differentiable such that derivative for fx plus minus gx will be equal to derivative for the single functions gx, fx and gx. Now, given fx and gx are differentiable functions, now by the definition for the derivatives, by definition of derivative, d upon dx of fx is equal to limit h approaches to 0 f x plus h minus fx upon h, and d upon dx of gx is equal to limit h approaches to 0 g x plus h minus gx upon h, where both fx and gx exists. So let it be one number 1. Now d upon dx of fx plus minus gx will be written as, now this becomes limit h approaches to 0 f x plus h plus minus gx plus h, one thing, negative of fx minus gx, sorry, plus minus upon h. Okay. By definition of derivatives. Now let us split this one. We are having, now this becomes limit h approaches to 0 f x plus h plus minus fx upon h, one thing, sorry, here it will be only negative, I am sorry, it will be negative, and here it will be plus minus. Okay. So we are having limit h approaches to 0 g x plus h minus gx upon h. Okay. Now this is equal to f derivative x plus minus g derivative x from 1. Hence d by dx of fx plus gx is equal to d by dx of fx, sorry, plus minus d by dx of gx. Proved.